Okay, sir. Thank you, sir. Good evening, everyone, and welcome you all. Myself, Sujata, Assistant Professor from Triple Department. Today's guest is Mr. Vijay Shanthagiri, sir. It's my pleasure to introduce Mr. Vijay Shanthagiri, sir. Sir is the founder and CEO of Analogica Software Development Private Limited, Bangalore, and Certitude.com. Vijay, sir, obtained his BTech in Electronics and Communication and MTech in Space Systems Engineering from MIT Manipal. He has worked with various DRDO divisions, ISRO divisions, Army, Navy, and Air Force for over 12 years developing software for C4ISR. Sir has core skills in programming, requirement analysis, software systems design, data analysis, statistical analysis, machine learning, artificial intelligence, cloud engineering solutions. Sir has patented a unique fast feature engineering algorithm for feature extraction of time series data. He collaborates with researchers and academians across the world to develop new and improved prediction system. Mr. Vijay sir started Certitude in January 2020, which is an edtech platform with focus on certifications in emerging technologies. Certitude has garnered great success owing to expert knowledge transfer of critical technical skills in the area of data science, computer programming, artificial intelligence, and machine learning. Certitude is rated one among top 5 institutions for machine learning and placement in Bangalore. Mr. Vijay sir is the recipient of the President's Award from Honorable President of India. Sir currently serves as CEO, data scientist, data product developer, and mentor with Analogica. His company is into data products development, artificial intelligence solution, AI pipeline integration, cyber security, and cyber forensic consulting. Thank you, one and all.
Thank you,
Sir,
Sujata madam.
sir, I happily welcome you, sir.
Oh.
Thank you, Sujata.
Thank you, sir.
Thank you, madam. So
Okay,
now
sir.
I hand over this session to Mr. Vijay Shanthagiri, sir.
Right, sir. Thank you so much for that introduction. So I'm Vijay Shanthagiri, and with your permission, sir, may I share the screen?
Okay, sir. Okay, sir. No problem.
So is my screen visible?
Visible, sir.
So, ladies and gentlemen, professors across different disciplines. First of all, I'll thank the institute for inviting me for this prestigious event. I've been a part of TLFTB quite a few times earlier, and in different capacities, I've been invited to talk on AI for different applications. I'm predominantly from Analogica. I founded Analogica in the year 2014, and what we do, what we are, is something which I'll be showing up now. We are we have we started in 2014, but our first projects and our first success started in 2018. So we are a Bangalore-based software development firm, and our expertise, as you can see here, is around AI product development, data mining, process automation, software development, and predictive analytics. And our products, what we have written for different agencies, are one is RSTK, it's a remote sensing toolkit, and another one is the data mining software called FlagX. It flags different events after mining data. So there are different kinds of research and development activities going on at Analogica in association with different universities, different organizations. A few of them have been listed here. Much of them are very recent developments, so that have not been listed here. Basically, wherever there is a problem that can be solved using AI, we put our we combine our technical expertise with that of the domain experts from the industry, and we develop certain solutions. So in the year 2020-ish, we started Certishort, which was purely based on the idea that a lot of people were joining our organization. They were getting trained, and they were getting better and better offers with Analogica. So we realized that the kind of training that we are giving them as a part of our company, that can also be given out as a product. So under the banner of Certishort, Certishort stands for certified for sure, because we not only train, we emphasize more on the assessments part. So with that, this is our office in Bangalore, in Rajajinagar, and uh, uh, we basically provide the courses which are around these technologies: machine learning, AI, data science, cybersecurity, cloud engineering, digital marketing, and computer programming. And we also provide boot camps and workshops and long-term certification courses for different requirements, right? And so we have certain academic collaborations as well, as you can see on the screen here. And there are many more, but this is what uh, we have written to this slide. These are the companies with which we have collaborations, with the hiring partners, and many of our students, about 500 to 600 students, have already been trained in place. So these are the companies where they're working right now. And we have another program called Certishort Unitrack program, which combines our academic programs with the universities track. Especially autonomous colleges have the flexibility of including our industry grade syllabus into their own syllabus, which makes the students placement ready, and at least they get paid internships after they finish their course. And to get in that, we created the Unitrack program from Certishort, and this has been well received in the industry as well. Anyway, so right now, what I've been called to talk about is the topic of AI for predictive maintenance using artificial intelligence. Right? And especially the area that has to be addressed, as I was told, because the Atal FTP itself is around renewable resources. So with respect to that, I've created a flow of concepts as well as some case studies, and we'll discuss through that. Meanwhile, could you also, if people here, I'm going to be using the chat because everybody may not be able to, not be comfortable saying yes or no or talking. So I just type in. Just let me know how many of you are um, aware of different machine learning models. How many of you are, or how many of you are new to this? How many of you are aware is something, yes or no? If you can give me a yes, I can just get a count and a feel for the audience, what kind of, so that I can mold, I can probably give you a deeper insight into that. If everyone is already aware of it, then I can go into the main aspect of the predictive maintenance itself. So how many, can you just type in there? I have sent you a chat message here. If you can just type in the message, that will be great. Yes or no? Like if you are aware, then you can just say yes. Or if you're not, then you can just say no.
Sir, your voice is low, sir.
What about now?
Okay, sir. Good. Good.
Is it good? Okay.
Okay, sir.
So as I was saying, I have put a message in the chat bot, the chat window here, and I've asked a question: how many of you are aware of different machine learning models? If you can say yes or no to that, that will be really helpful for me to, do the right combination of the delivery of this knowledge. No, sir. Sir, can you tell them to at least type in yes or no to that message that or are they able to see the messages that I've put in? Okay, I'm receiving 3 no's, so not aware of machine learning models. Fine. No. Okay. Okay. Fine. So no problem. I will try and explain the gist of it, but let me start with a story. Okay. So a story is good to start with. It helps us to connect with the ongoing context of what we are going to speak now. So the story goes like this. Once upon a time, there was a company called Prime Tech, as you can see on the screen here. Meanwhile, let me one second. Just a moment. Let me adjust my. Mhm. Okay. So, as you can see here, in a bustling industrial zone, there was a company called Prime Tech, and it was a leader in producing precision parts for aerospace companies. Okay, so that's the story. That's how the story goes. And their production line relied heavily on a state-of-art CNC machine, and those machines were like continuously running for years and years and years, producing any part. It can be any part. It can be a hammer, it can be a spanner. So these machines, they just are put on load 24/7 because there is product requirement to be met. Now the machines are also, they need maintenance, right? They may fail in producing the right kind of quality, or sometimes there are a lot of orders, but it so happens that it can shut down. But most companies, what they do is they go for a reactive maintenance strategy. Most companies, and this has been the case without any choice. This has always been the case when there was no AI. So what is reactive maintenance? Reactive maintenance, as you can see here in the yellow line, fix it when it breaks. So reactive maintenance is about fixing the problem when the problem appears. And usually it works well. And even with this company, Prime Tech company, it worked well until one fateful incident. And what was that incident? One of the chilly Monday mornings, the CNC machine emitted a subtle, unusual vibration. So the operator dismissed, saying that something might be wrong, and just ignored it. And by Wednesday, the vibrations intensified. and then was an odd whining sound accompanied by it. And then, even then, there was no action taken, right? So they just said there is an order, there are a lot of orders, let's just keep the machine running as long as it goes. Because they were seeing that the machines were still producing the parts or the product within the tolerance range which they had. So it kept on going. But then Friday arrived and a disaster struck. There was a catastrophic failure caused by spindle, and the operation ceased in the middle, right? And it not only damaged the bearing, but also the high value part it was machining, like the high value parts that it was producing. It damaged everything, the raw materials, resources, everything got, right? And eventually the repair of that exceeded about 15 lakhs, and the downtime resulted in missed deadlines, loss of trust, and then the penalties. Of course, when you don't deliver the product in time, there's a penalty. That's what happens in big companies. So what we understand here is when you keep a machine on without the required maintenance, there usually is a maintenance time involved. But sometimes you'll never know when the machine breaks down. Is there a way to know it in advance? That's what predictive maintenance is, the predictive maintenance alternative. So what this company did eventually was the factory's management was forced to rethink their maintenance strategy. They consulted the experts, and then the experts introduced them to predictive maintenance powered by IoT sensors and machine learning algorithms, right? So then another case happened, and some other time what happened was, again, these vibrations occurred, but this time because they had IoT sensors and a machine learning algorithm attached with this process, what happened was they were able to catch the potential failure event much before it actually happened. So hardly small investment of 25 to 30,000 rupees was enough to bring the experts and get that fixed in the normal downtime, which is a part of the project. Am I making sense so far? Because I just want to know, right? Type in a yes if you understood the story. Because if you don't understand the first part, then you will not be able to connect with what is going to come next. Were you able to understand the story? I would like all of you to type in. I'll appreciate all of you to type in, right? Because it's interactive. If you interact with me, then you can get more from me. Others? If it is a no, it's okay, fine. You can tell me if it is a no. I'll summarize the story again. If it is a no, I'll summarize the story again. Thank you, Anu, and thank you, Neha Prakash, for your response. Anyone else want to say yes or no? Okay, moving forward. I got a yes only from 2 people. So does it mean that the other people did not understand the story? Let me summarize just in case. Okay, there was a company which operated a CNC machine. That machine, suppose, was designed to create hammers, continuous production of hammers. And one day it started making a sound. The vibration enhanced, but no action was taken. Eventually, what happened? Eventually, one day, the machine broke down. And then it caused a big repair cost of 15 lakhs. The downtime resulted in missing of the deadline, because once a big problem happens, the machine has to be shut down. And what about the clients who are waiting for your product, right? Their schedule will be missed. They'll penalize you. Then the client will lose trust in you, saying you don't have the right process, you don't have the right technicalities to continuously give me the promised product. These are the kind of problems which happens when you don't maintain your system. But what can you do? You will never know when the system goes wrong. And what do? Can you just bring a consultant or a technician every day to remove the machine and check if something can go wrong. We can't do that either, right? So one of the solutions is predictive maintenance, right? So that is what we are here to do, to understand predictive maintenance, especially with renewable sources. So we're going to be talking about all these um, mechanisms like wind turbines and solar panels and how these things affect. The concept is much simple once you understand machine learning per se. So I'll be connecting. I'll be talking about machine learning in the context of predictive maintenance for renewable sources, right? And so what happened eventually? They gave a solution saying, you have to implement IoT-based machine learning algorithms. And within weeks, what happened? They implemented sensors were installed on all critical machinery, including CNC machines. These devices monitored vibrations, temperature, and acoustic emissions in real time. Data was fed into an AI platform which identified patterns and flagged anomalies early. So this is what is predictive maintenance as a part of the story that I mentioned. Now, the summary or the conclusion of that story is, had Prime Tech adopted predictive maintenance earlier, the original failure could have been avoided entirely, saving company millions of dollars and preserving its reputation also. This incident, what happened with them, it served as a wake up call, demonstrating that investing in modern maintenance solution was not just a cost, it was a safeguard against preventable losses. Right? So that's what the moral is. Moral is, ignoring small signs can lead to big problems. But with predictive maintenance, you can catch issues before they snowball into a big problem. Now, the key point here, the key observation point here is ignoring small signs. Now, how do you not ignore small signs? Where are these small signs? The small signs are always there. The small signals are always there in a machine. A machine emits. Machine has a reaction to the world. If you start on a machine, there is vibration, there is pressure, there is temperature. And what if we can sense all of them? That's what the IoT sensors are. The Internet of Things sensors, the small sensors, which are all collecting that data and logging that data in a certain place that is being engineered by the data engineers to be collected in one place. Once the data is getting updated in real time, on that data, we will use that data to build a machine learning model. Right? So I'll demonstrate. We have all the, let me just check if I have the demonstration with me. Okay. It's there. Right. So that's what the whole thing is. And the stats says that even in the world today, unplanned downtime, this yellow color thing you can read, the unplanned downtime costs Fortune Global 500 companies approximately 11% of their yearly turnover. Okay, 11% of their yearly turnover. Statistically, it's been proved or it's been observed that it is going to cost at least 10 to 11% of their entire turnover itself is being spent on the unplanned downtime. You should understand there is always a planned downtime. Means if your machine is running, they know that we have to switch off the machine for some time, give it the right lubrication or give it enough time to cool down. That is planned downtime. Suddenly something goes wrong, that is unplanned downtime of the machine, which results in close to about 1.5 trillion annually of all these 500 Fortune 500 companies. Now you can understand what is the potential for somebody who can really implement predictive maintenance using AI for these companies. If 10% of their annual turnover, if 10% of annual turnover is being utilized or is considered as a loss, don't you think they'll be ready to invest in predictive maintenance using AI? Yes, so that is one of the trends, future trends, where IoT and AI is going to be combined to give you that. Is it making sense so far? Where I'm trying to get? What am I trying to, tell you? Is it making sense? A yes or no, please. I summarized now. Is it fine? Did you understand? Am I talking too fast, or is my pace? Am I audible? Yes or no? You can type in yes or no. Am I audible? Is my delivery speech or the rate of speech adequately, paced so that you can understand what I'm trying to say? Am I speaking faster, or should I slow down? Yes, sir. AFP is good. Yes, thank you so much for the response. It really helps, so that I can maintain, because it's all about you spending 90 minutes of your precious time, so that it makes sense for me to ask you this question and get that important, right? Now, same story, something similar. Let's talk about predictive maintenance using AI for renewable energy resources. And imagine a wind turbine generating power for an entire community and it suddenly stops due to gearbox failure. Now, the downtime costs thousands of dollars every hour, repair delays affect energy availability, and the question is, what if AI could predict the failure weeks in advance and prevent it? So we talk about smart cities, we talk about renewable energy continuously powering our houses. If we are building a future where this energy is in constant supply, that is the only way when companies and governments will adapt these technologies. Only when you can promise companies that, hey, you don't have to worry, we will give you continuous supply of energy. Let's all shift to renewable sources. And unless you have some kind of predictive maintenance in place, you cannot promise it, right? So, how do we do that? How do we develop something like this? Now, talking about the industry context, the challenges, the energy growth and the challenges. Renewable energy growth, there's a lot of investment happening. What are the challenges? Now, here you can see the point here. High dependency on continuous operation. Now, if you talk about this wind turbine, once it starts, it's going to be continuous. You can't stop it because people are waiting for that energy to reach their homes or the turbines or wherever that energy is being utilized, maybe converted to electrical energy and then transferred on to different plants or different industries. They're waiting for this, right? So there is a high dependency on continuous operation of this machinery. And then these renewable energy resources are are actually exposed to harsh environments all the time. Example, wind turbine in high altitudes or offshore, and solar panels is exposed to extreme heat. That's what its job is. So it becomes more important to involve predictive maintenance for renewable energy resources, because these machineries are always in harsh environments. Correct? So, and to understand a little more into this context, the key definitions that we're going to be talking about here are predictive maintenance. In short, I'm going to be using PDM here and using AI driven analytics to predict equipment failures. Will the equipment fail, or will there be a projected spike in heat, or is the pressure increasing and will that lead to a certain dangerous situation later? All these are always certain areas to be monitored continuously. Now, why is AI critical for renewable energy? Because systems are complex. The data that gets generated here are large, and this is the time when real-time decision making is important. Real-time decision making. So, the problem with real-time is, first of all, there should be continuous monitoring of this data, and the sensors that you use should be very good. The data engineering pipeline that you adapt or you use in this particular kind of blueprint of the scenario, where you're maintaining or predicting failures in real time, these all have to be top-notch technology. But then that's fine. I mean, that's what engineers are, or that's what systems engineers are for. And whenever you see somebody call themselves a system engineer, Then, okay, of course, control system engineer, space system engineer, and different kinds of. So there'll be maintenance engineers, and maintenance engineers will eventually be trained on predictive maintenance as well. And many companies are already making frameworks ready to, deploy products for predictive maintenance. They're doing it. So we'll learn about a few of them later. Now, talking about the solution, we come here to this part where we now introduce ourselves. We start discussing on the concepts of ML-based algorithms, machine learning-based algorithms, and they have now made a substantial impact across various engineering and scientific domains, particularly in those areas where the data sets are very large. And what they do actually, or these machine learning algorithms actually do, is they establish a functional relationship that map the input variables to desired target quantities. Now, for all those who know machine learning, they will connect with this. But for all those who don't know what this means, I will help you to understand it. For that, I can, since I saw a lot of no's when I asked whether you guys know machine learning adequately or not. So I'll not leave it to chance. I'm going to give you a small introduction. We are going to understand what ML is, and we can take this opportunity to think about these ML problems, right? So let me show you what I'm going to be talking about. Introduction to key concepts of machine learning and AI. I just wanted to introduce briefly, but now that I know that you need a little bit, so we'll spend some time understanding, and eventually I'll summarize everything in the context of predictive maintenance for renewable sources. It doesn't matter. It doesn't matter whether your data is for renewable sources or whether you are actually going to do a predictive maintenance for some CNC machines, or whether you're actually going to do predictive, or you're going to build an autonomous vehicle, or you're doing a fraud detection. It doesn't matter, because the thing is, as I told you here earlier, machine learning establishes a maps. It develops a functional relationship that maps input variables to desired target quantities. It doesn't matter where that input variable is coming from. It can be text, it can be numbers. So that's why we are going to talk about types of data in the beginning. Just okay, types of data. Here, what you can see, types of data in the beginning, and types of machine learning models, regression, classification, and reinforcement learning. We'll talk about what is a machine learning model in terms of algebraic context. I'll discuss. We'll also discuss deep learning and machine learning and a little bit of LSTM networks. Then creation of a machine learning model, how it gets created, what actually happens. We'll work on that. Okay. Let me just fix my pen tablet, because if I write, I think you will be able to engage better. Thing is, I have to fix this problem. One second, let me just get that pen tablet. I'm here. I'm just trying to get that pen tablet so that I can write on the screen. Just a moment, please. With the pen? Okay. Thank you. You can take that and see what's wrong with that. So thank you for your patience. I've been able to fix that. And let me grab my. Okay. So we're going to talk about this aspect first, types of data. Okay. The types of data. Okay. So see, what happens is, first of all, there is an event. There's an event which happens. In our case, that event is some turbine which is moving. Okay. And you can see all the different mechanical parts of this. The speed of the rotor, the blades, the pressure which the blade is experiencing because of the wind density or the wind speed. All of this gets collected. In fact, I can show you a real data, okay, of wind turbine. I have it here. So let's see this. Okay, so you can see this. All of you are able to see vibration level. Are you able to read this, or should I zoom in a bit? Let's zoom in. Okay, this is how the data gets collected. The one which I just said, some event has happened, and there is a sensor which records the level of vibration. Then there is a sensor which records the temperature right now, the wind speed, the rotor speed, the power output that is being given, the gearbox oil level. Okay, this is one of the important values. Then there is hours since the last maintenance, and how many hours has elapsed since last time you maintained. So this data is collected data. Sometimes what happened when the temperature was 27 degrees and the wind speed was so much and the rotor speed was so much and the power output was so much, when the gearbox oil level was so much, then and then it had been 324 hours since the last maintenance. Did it fail? No. So that's the data that gets collected. Okay. Next time, for a different vibration level, you see 4.7, now vibration is high, temperature is high, wind speed almost same, rotor speed is less, power output is more, gearbox oil level is almost same, but hours since last maintenance was 86, but it failed. For different numbers, there are different. So you see the data type here is what kind of data type are these, what you're seeing right now. These are all numbers. Another example, I think better view of this would be, let me see if I can get that for you. See here, this is actually a online statistics calculator. If you if you would like to do some statistics calculations automatically instead of worrying about machine, Python programming and everything, you can directly use this. And I would take this opportunity right now to introduce you to Data Tab, which is Austrian software. And why am I introducing you to this? There's of course a hidden or selfish motive, because we are the representation. We represent Data Tab in India. It's an Austrian company, but when you try to buy it, it will go to Turkish short itself. So we represent it. But I mean, I'm proud of it that we represent it because it's a fantastic tool. Because see, you see this data here, because I'm talking about data type, you have to understand. These, you should just see, these are also numbers. Variable name may change, right? See, this is what hypertension. Whether a person has BP or hypertension. Yes, no, yes, no, yes, no. So what kind of data? As you can see, it is nominal data. And these moving numbers, these are metric data. Okay, metric means your quantitative data. So overall, your data, no matter what kind of experiment you're running, events produce what? Events produce data. Because when you attach the event to a sensor, if you observe this event, using a sensor, what you eventually get? Data. This data, this sensor is sensing this event, producing this data, and this data in itself can be of many types. Basically, it is either a qualitative data or it is a quantitative data. Okay, a quantity means numbers, quality means text or symbols. Both of us makes sense to us. You can collect, instead of 0 or 1, failure or yes or no, you can write, right? Somebody will collect it as yes, no, failure, yes, failure, no. Instead of the 0, 1 which we just saw, we could have just recorded yes or no instead of that. It doesn't matter, right? Whatever kind of data we have, eventually your machine learning algorithms are interested in not what kind of numbers you have. They're interested in what do you want to predict. What do you want to predict? So the thing that you want to predict is called the target vector. Remember this. Okay, the thing that you want to predict is called the target vector. Now it will say, based on what should I predict? Correct question, right? Okay, fine. I'll try to predict, but based on what? So we'll give an answer to this. We'll say based on, the answer to this will be based on previous data. Now, where is that previous data? We just saw one of the glimpses of this previous data here. So the algorithm will ingest this data, but now we have to tell the algorithm, see, boss, this is my target vector. What you're seeing here, all of this is my target vector. And based on all these other inputs, you should tell me whether the machine is going to fail for a particular value. Now you see, all this data is in front of you. Let me get back to this. All this data is in front of you. And I told you what machine learning algorithm does. It actually builds a functional relationship, an algebraic relationship. Algebraic relationship between what? Algebraic relationship between these feature vectors and the target vector. I want an algebra to be defined between this feature and this target. Now you see, these are all moving numbers, continuously moving, right? But this is what? Nominal. Yes, no, yes, no. But these are all not yes, no, yes, no. These are all continuous numbers. So now you're building a model between metric numbers as features. This entire thing is feature vector. Everything here. This is a target vector, failure. Right? So say this is a target. You are supposed to tell me, or you're telling the machine learning algorithm that you are supposed to understand what is the relationship between vibration level, temperature, wind speed, rotor speed, power output, gearbox, and our since last maintenance. What is the relationship with this entire set of variables with it being failed, right? It failing to correctly, express it. So suppose now what is happening? I told you, like for these levels, suppose I want this now. Next time, this is the value. This is the temperature. This is the wind. This is the rotor speed. This is the power output. And this much is the gearbox oil level. And this is the hour since last maintenance. Now this, for this data which has happened, we don't know whether it's going to be a failure or not. I want the machine to understand. Next time I see these values, can you tell me whether this machine or with this one wind turbine will fail, or is it about to fail? That is what we want the machine to learn. So I'll give you a small insight, or I'll sort of um, show you by hand how this relationship gets established, and then we'll start making sense of all different methodologies. Okay. Now, can I get a yes or no if you understood the problem statement of a machine learning algorithm? I'm not explained machine learning yet. I've just built the context. Can I get a yes or no, please? Did you understand this? What I was trying to explain, the target and the feature, and what is it that we want to predict? You can, so if you don't like typing, then you can just unmute and say yes or no. I'm okay with it. No? No yes or no? Is it making sense? Did I make sense with what is happening? If it is a no, then I can re-explain. Making sense. Okay. Okay. So let me go to the drawing board and show you what a machine learning algorithm looks like. Get here. Let's suppose we have age, and let's suppose we have salary. Okay. For somebody who's aged around 28, let the salary be around 10 lakhs. Okay. Somebody around 32, let it be 60 lakhs. Somebody who's 24, let it be 8 LP. Okay. Somebody who is 45, let it be around 32 LP. Okay. So, and someone else who's around 50, let it be 5 LP. So let's plot this. Let's plot this. This is x-axis, this is the y-axis. Okay, I've got on x-axis I have age, right? On x-axis I have age, and age goes from 0 to 100. Okay, and we have 10, 20, 30, 40, 50, so on and so forth. We get 100. Okay, only till 50 I have, so I am a plot that. And this one goes from 0 to 40 LP, right? So 0 to 40 is around, okay, 5, 10, 15, 20, 25, 30, 35, 40. So we have 5, 10, 15, 20, 25, 30, 35, 40. Let's bring some data dots now. Okay, I'm going to bring the dots. I'm going to bring it. Okay. Let's see. For age 28, what is the salary? 10 LP. 28 is somewhere over here. So like this is one data point. The first data point. For 32, we have 16 LP. 32 is here. And we have around 16 LP. Fine. Then we have 24, which is here, about here, and that is 8 LP. Okay. So we put it here. Then we have 45, which is here, and it is 32 LP. Is here. Then we have 50, but it comes to 5 LP, which is here. So if you sort of build a progression for this, the graph moves like this. Now, when I said I'm going to establish a functional relationship between these variables, my target is y, and I want to predict what now? Am I going to predict age if you give me salary, or am I going to predict salary if you give me age? In this case, I want to predict the salary. So let me create a new person here who is about 35 years. And I want to know for 35 years, what is the predicted salary? How will you predict it? So I want a relationship between salary and age. Something like I want salary is equal to something related to age. That's the relationship I want. And the relationship is already in front of you now. Now, all I want to do is fit a straight line to this. Now, when I try to fit a straight line to this, suppose I bring in a line. If I fit the line like this, I'm covering maximum number of points. Correct? 1, 2, 3, 4. But I'm going to be missing this point. So this 50 years old person with 5 lakh LPA, 5 lakhs per annum salary, this person will be missed. Now, if I try to include that person also, then I'll end up with a line like this. But then I'll end up missing these 3 people. So I have to make a judicial decision here to include maximum number of points on my line. Okay. And we all know the equation of a straight line is y is equal to mx plus c if the coordinates are named y and x. But in our case, the coordinates are salary and age. So we say salary is equal to m into age plus c. Okay, so I want this m into age plus c. So what is this m and what is this c? So this c is this point where it touches. So this could be, I think, minus 10 if you look at the scale, or maybe minus 15 is also fine. So this is C. And what is this M? M is the slope. M is nothing but dy by dx. The change in y that occurs when there is a change in x. How much y occurs when there is a change in x? So if you can see this, wherever you go on this line, for equal amount of change in, suppose here, you see, I'll build, I should have built it there. Wait, let me drop this and I'll build it there. Between this. Let me go from here to here. So there is a 10 difference, right? 20 to 30. 10 unit difference. 5 to 15, almost same. See, this is 5, this is 15. This is 20, this is 30. So what happens? Almost this ratio and this ratio will be almost equal to 1. So not almost equal to 1, so I would just say 0.98 here. So M is 0.98 into H plus C. Now the C becomes, what is that C we got? Minus 15. That was minus 15. So eventually this new equation is 0.98 into H minus 15. Now this becomes the new model. This is your machine learning model. This is just for two variables, out of which one is the feature, other one is the target. Target, the feature. Okay. This what you just saw is called linear regression. Now the question is, how did the machine, because we are three-dimensional people, you're all seeing the problem, but machine is not seeing, right? Machine is only observing, feeling numbers. Now, how did you make the code come here and make a line? That is the implementation of the problem. That is a machine implementation that I cannot explain now. Okay, it's beyond the scope of a small discussion or the time that we have, right? So this, what now we can actually check. What did we want? We wanted 35, right? For 35, how much is the salary expected? Let's put that and see. 0.98 into 35 minus 15. So this remains about 35. This is minus 15, so you're getting 20. So for 35, you're expecting 20. Because it's in the trend. It's there. Exactly there. For 35, I'm getting, of course, if I had to draw a real straight line, okay, even then I'm getting about 20. You see, this will be 20, but I'm getting a little more because I would have gotten this number 0.98 into that, and roughly about that. Now, don't you think we've built an engine or we've built a model now to predict everything here? Every salary I can predict. I can now predict for 18. But when it comes to 48, if you put 48 now, almost you're getting 0.8 into 48. So let's suppose you're getting 47 out of it, minus 15. You're looking at 32 LPA. So somebody who's at 48 is going to get around 48 will get around 32 LPA. Okay. But 50, again, if you check for 50, you will get the same. Why? Because this outlier was never considered. And you must be wondering, because of the trend, what is this 50-year-old person getting 5? Because you'll never know. Because the 32-year person could be techie, 45-year-old person could be also a techie, but this 50-year-old person could be a watchman. You'll never know, right? So these kind of anomalies will occur in your data because event is that innocent. Event is random. It's up to us to collect that data, make sure that, so this removal of this removing this point and considering saying that, hey, I will not consider this particular data which is out of this trend. Removal of that is called, we go back here and show you that. See? So the removal part is this part, data pre-processing. So I have to pre-process this data before I bring into that context, right? So once I remove all that, then I start applying linear regression. So this, what I explained to you right now, is regression. Why? Because in regression, what happened? Both were moving numbers. So sometimes it may happen that these could all be moving, and these can just be zero or one. At this point of time, you can't fit a straight line like this. It doesn't make sense. So you will fit in a different kind of curve. That curve looks something like this. Now this is logistic regression. It's a very good classifier. For simple set, this classifies very well. But then we also wanted 0 or 1. This can be failure, correct? According to this data that we had, failure, 0 and 1, 0 and 1. But we are not just building a model where we are only checking vibration level. If suppose we were building a model which based only on vibration level, then a logistic regression would help. But for us, as you can see, we have many features: vibration level, temperature, oil, and so on and so forth. So many were there. All of this should affect whether a system will fail or not. You want to check my machine. Now, I want my machine to understand that. I want my machine to understand how, whether the machine will fail or not, how will it depend on all the features. Here what is happening? We were trying to build a model. Where salary depended on the age, but salary actually doesn't depend on the age. Salary depends on skill, salary depends on experience, your education level. So many things are there. Here also, this is just an example. In reality, problems are not as simple as we just showed. But to understand the inner working of it, we were discussing it. But in reality, we need different kinds of problems, different kind of setups. So with respect to this concept, thank you, Shubhashini. Thank you for the appreciation. Is it making sense so far? Did we understand this? Did we understand how simple it is? Because we are here to make life simple, right? It is simple actually. There's no, as long as you don't understand it is complex. Once you understand it, is math is supposed to make everything, right? So can we get a yes or no? Can I proceed further to go into the section where I talk about types of machine learning? Because you just observe, we just saw one of the types, which is regression. Now I want you to understand the types of machine learning itself. I'm not talking about different kinds of machine learning algorithms. There are different kinds. There's a linear regression. Then I showed you logistic regression for classification. But overall, machine learning are of different types. Can we move on there? Anybody has any doubt when I explain with that? Did anyone have any doubt with this? Because for all those people who told me that you have no exposure to machine learning, I'm asking you people. Any doubt here? Anything that you don't understand? Okay, so I would say if you don't answer, then I will be a positive person and conclude that you haven't. Okay? Now I'll take that liberty to be positive about it. And let me move on with what I had next. Let me just check. Okay, types of machine learning, regression, classification, reinforcement. Of course, this time is not enough. There is so much here to learn, and I haven't even come to the main features. But let me try as much as possible, not to bore you as well as to quickly get to that. Okay, so the machine learning are of three types: supervised, unsupervised, reinforcement. In the middle of it, there is one more called semi-supervised also. But then, if it comes to creating new types, you can keep on creating. Basically, these three are the ones: supervised learning, unsupervised learning, reinforcement learning. Okay, because see, we are all professors, you're all professors, and I am also in EdTech, so we know what learning is, because we are always trying to facilitate our students to learn. Okay, when it comes to supervised learning, in this case, in this particular case of linear regression, when I try to build the model, I gave the data set, this particular data set I gave to the algorithm, and I clearly say, this is my target vector and this is my feature vector. I clearly tell the machine learning algorithm, but you have to build a model where I get salary is equal to, or build a relationship between salary and age where I can predict the salary. This is what I'm clearly telling my model. So in your data set, like this, in your data set, if you clearly mention what are your feature vectors and what is your target vector, when you clearly mention it, you are supervising the learning. It is supervised learning. Because you are the supervisor, you've told that, see, I'm giving the data, I'm giving you the relationship also, observe it, check for different values of all these variables, when all it has failed, when all it has not failed. That is what I want to monitor. If you clearly mention it, that these are my features, this is my target, and I want you to build a relationship between target and the feature, if you clearly mention it, it is called supervised learning. But sometimes we ourselves don't know, or we are not clear which one should be the target vector. In situations like that, we go for unsupervised learning. What unsupervised learning does is it sort of clusters everything. Okay, it goes into a cluster mode. So we call this also as clustering. Sometimes what happens after you see the cluster, then the data itself starts making sense. Then you start asking many questions like why these value, this value, and this value, and this value is clustering together. So sometimes, when rotor speed, actually, accidentally I just put this, but if you think about it, if the speed is increasing and gearbox oil is decreasing, then the vibration level will increase. So somewhere you will see this cluster happening. If the wind speed is high and if you have power output is also high, then vibration will also be high. Think practically, right? Lot of wind, it has to move against it. It is moving faster, so rotor speed is high, so power output is also high, right? So wind speed is high, rotor speed is high, power output is high, vibration level is high. So the machine learning algorithm, you will eventually understand that whenever these levels this vibration level is high because of these, and these, then it will observe that you will see ones happening more often. Now it will make a relationship. Now that relationship is not like this. Okay. It eventually is like that. It sort of resembles it, but it is not as simple as a y is equal to mx plus c. Okay. It is going to be a little more complicated. This is called multivariate analysis, by the way, because that was univariate. It was two variables. And instead of just y is equal to mx plus c, you will have something like y is equal to m4 x raised to 4 plus m3 x raised to 3 plus m2 x raised to 2 plus m1 x raised to 1 plus. Now this is a monomial equation. This is a polynomial equation. So we call it polynomial regression. But this happens, but see x is same. I'm not putting x1, x2, x3 here. X is same. This when it happens, when polynomial regression is used. Polynomial regression is used when features are same, but your data is moving like this. Now we can't just try and fit one straight line here. I want to bend this line, and I want to bend this line. I want to bend this line. So if I bend this line to fit this data, the bending will produce different dimensions here. That's why different slopes. There is one slope for this, then another slope for this, another slope for this, another slope for this. That's why you see one more slope, another slope, another slope. So more bending happens, and you don't have to completely fit the data. If the data is like this, you can just say, I don't want to fit the complete. I will just be happy with something which goes like this. So less bending. 1, 2, 3, 4. So in four terms, you're done. Okay. We can't predict exactly, but that is fine. But as long as the equation is reproducible, equation is real, right? So now what happens? I'm talking about what? I'm talking about not just a single x. I'm talking about x1, x2, x3, x4, x5. What are these x1, x2, x3, x4, x5? These. x1, x2, x3, x4, x5, x6, x7, and y. Now this one is multivariate analysis. Okay, and when this happens, we don't go with regression. It doesn't make sense. We can't even put a logistic regressor there, right? So we will now go to something like a decision tree or another algorithm called random forest. So there are different algorithms, and for all of you people, if most of you people don't know, then don't worry. We have a lot of 15 for professors. We have a lot of FDPs going on in our organization because we are connected with many universities, right, in Bangalore. So when a new batch or new from a different background, from electrical, from mechanical, when these professors want to learn, so we arrange a full 15 days program for them so that we can make them all understand how all of these algorithms work, why different algorithms work in a different way. We have a complete 15 days program for that. So if anybody is interested, then I'll share my number with you. Then you can let us know. It keeps happening once in 45 days or once in 2 months. The next time it happens, if anyone is interested in taking the entire, our team is going to help you gain that knowledge. So that way you can, gain from. If somebody is getting more interested in this and want to know more, then you can definitely learn. And so the next aspect, what I'm going to be talking about is that. So we come here and we see we finished supervised, then we finished unsupervised. Then reinforcement is a little difficult, but reinforcement is like learning from mistakes. Okay, reinforcement is more like In real time, we are training. That is how uh, autonomous car is trained. Autonomous car, self-driving cars. Self-driving cars have a lot of adaptive quality to it, because you leave a self-driving car in the middle of a traffic, there are so many things that can go wrong. Imagine the level at which it is trained to understand all possible faults, all possible mistakes that can occur, right? So you go and check out in your own capacity what reinforcement learning is. It is very complex, but it is the future. It is already there, and whoever can implement reinforcement learning, they are really going to be next level, right? So these were the three different kinds of learning, and because I'm looking at the time, because my time given is 7:30, so I want to summarize as early as possible, right? So let me show you a machine learning pipeline, and quickly I'll come to case studies. This is the machine learning initial data set. You see here, what you're seeing is the initial data set. What you do is you clean the data, you curate the data. Means clean is mismatch and some columns are missing. So what do you do? What do you do when this value is in there and this value is in there? What do you do? Will you remove this entire line just because you are missing some values? Or we can do what? We can just take the average of this entire power output and put this here. Or we can take the average of the last four and the next four and we can put it. We can decide. There will be many, just so that why? Because just so that we don't lose this information, right? So these kind of curation processes happen. This is data pre-processing aspect. After that, what do you do? This is the training. Now what we do, we split that given data. So in this case, we have how much? We have around, this is a lot of data here, right? So we have around 1,000 data points, okay? So 80% of the data we will train, and 20% of the data we will test our model whether the model is performing well or not. So if I just can pull the code here, you see this wind turbine data.xlx. This is the one. This is the data. You see wind turbine data. I have loaded this data to my Python code. And I've said, create the data using this pandas library. And you read this data. Then your x-axis will contain all of this data, but you should drop this column called failure from the x-axis. That's why I said data.drop column name is equal to failure. So in that data means this entire Excel sheet is now in the form of table, it is in data. From that data table, you drop this column called failure, but you include that failure column as Y. Then we bring in another API called train test split. And we say you take the X, which contains what? Which contains all this. Not this, not failure, only this. X contains only this now. All this data, all 1,000 points as a table is contained in that X. And Y contains this failure. So we say you take that and you make a test size of 0.2. Okay, so test size means automatically I'm saying my test size is 20% of the given data. So 200 data points randomly you select. And what random state? We are just putting one random number here. Random state 42. So it will automatically pick randomly, it will pick some 200 points, not in sequence. Somewhere it will pick randomly and say I'm going to use this to test. Baki 800 points we'll use to train. And these are all the small print statements and head and all that we print eventually. So we get this, and then we bring in a random forest classifier. Because of the lack of time, I'm not able to explain classifiers. I'm already running out of time. Now I realize, first I thought 1.5 hours, maybe I can do this, that, and I have not even spoken or not even explained 25% of what I had planned. But maybe we can, if anybody is interested, I'll share some videos, a lot of stuff that we have already done. Um, I'll share it with you for those who are interested. Right. So once you build the model, this is a different kind of model though. Okay. All these explanations I'll give later. N estimators is equal to 100. So random forest means there are many trees that are run, and I want 100 trees to be created to decide. So eventually, all of this is going to happen. The machine will get build a model. Now let's just run this and see. Okay. Now this model is built, and eventually, what it is saying is that it's saying a lot of stuff. It is saying the precision of your model is like this, the recall of the model is like this, the F1 score is like this. So let me see if I have that with me. Mm, okay, I'll share this. Okay, what precision is? This precision, recall, F1 score are all metrics to understand how good your model is, not the model itself. Okay, you built a model, you built the relationship, but who will tell you that your model is good or wrong, good or bad? All these scores will be there. Okay, you put all that, it is going to tell us the accuracy score is 1, because this is a very nicely processed data, so you're getting a very good accuracy score. But now what do I want here? I've written the code in such a way that I can put in different data. So I've already selected some random data here, just in case you are not able to. Where did I select this from? I selected this from here only. Some 4. I took this one value here. I took another value here. I took an. So it is giving me the saying, I am ready with my model. So you enter different levels now, and I'll tell you whether your machine will fail now or not. Okay. So I've already copy pasted it here. So let me quickly put this copy, and I will put this here, paste. Okay. Now I just press enter. What it says, predicted failure, 0, no failure, 1 failure. And what is the answer it gave? 1. So for these values of vibration, temperature, wind speed, rotor power output, and gearbox oil, the machine will fail. Similarly, let's run this again and see. Run again. Again, the model got built. Okay, again the output came. Now I'll use a different level, some fabricated level I use. Simple. For this, predicted failure is 0. It won't fail. Why? Because for 2.5 level of vibration and some 60 level of this or 10 or rotor speed and so much power output and 300 hours of and oil level is 50, it won't fail. That's what it observed, okay, from data point. So it is so important. Now, when it comes to the real challenge of building a predictive maintenance problem, the problem is how will you sense this vibration level? How will you sense this temperature? After sensing it, where will you attach this? Where will you send this data? So to do all that, there are certain. Okay, so many things I could not, but I've explained. Machine learning model algebraic context is done. LSTM, no time for it. Data frequency, feature engineering, no time. Train test, I explained. Model accuracy, explained. Deployment scaling is once you build the model, it is going to be deployed somewhere on the cloud or wherever it is, right? And now, these are all different case studies that I had, where suppose in renewable energy, let's suppose in solar panels, what data you collect, voltage, current, temperature, irradiance, wind turbines as we just saw, battery systems, charge or discharge cycles, internal resistance, temperature. There is a sensor to sense all of this, but you should know where you're going to deploy that sensor, how will you collect that? So once you collect that data, what can you do? You can use these kind of different methodologies, time series forecasting, where you predict future trends. Then there's anomaly detection, where you identify unusual patterns, right? Then there is classification models, labeling equipment as healthy or requires maintenance. There's a label, or you know, these kind of stuff. It's especially big machines. Big machines, you can't simply open them. To open them, that requires big time decisions of downtime is required. Because suppose you simply try to open and do something and you don't put the nut or something properly, the vibration increases. You try to solve a 10 rupee problem, it will create a 1,000 rupee problem, right? So that's why vibrations, they sense the vibration, and that is trending right now. In fact, if you see ANSYS, there is a beautiful or a very complex and advanced software by ANSYS only for vibration engineering, and it is going to come now. And whoever have taken vibration engineering and all these people in Europe who studies vibration engineering, they are really going to be the future, right? Now there is also example workflow for this, a wind turbine example that I've already shown you. And what I was trying to show you was this actually. Okay? Sensors collect vibration, temperature data, and all the other data from the turbine components. Data is then transmitted to a central platform via Internet of Things. Then the AI models process this data to predict when the gearbox might fail or when the system might fail, as you see. ML models that can be used here, regression models for lifetime estimation. You estimate how much it's going to survive. Then there is LSTM, long short-term memory networks for time series data. I don't have the time to explain long short of memory. And if you're not uh, mm, exposed to machine learning and deep learning and all that, then suddenly bringing you to long short-term memory is like, in the first day when I've not even told you about Ram and Lakshman or Sita, and suddenly I'm talking about Hanuman meeting Sita, right? So you will say, who's Hanuman, who's Sita, right? So something like that it will feel. So we'll see when next time when we can meet, I'll probably explain the whole thing. Now the tools which are there in Python libraries, I use scikit-learn, TensorFlow, PyTorch, all this. Here also I've used scikit-learn in the previous example. These are all libraries which are already readily available. All the features are available now. So actually, today's generation AI, the how is not a problem. How to build a model is not a problem. When to build a model, why to build a model, where to build a model is the problem. How AI is already mastered. You ask how do I build a this, it will give you the answer. You ask how do I do a train test, it will type you the code. But who's going to tell you when to build it, why to build it? That is from your vision, right? So that's why at the end of this one, I will share this video. This is what this video was. Okay, this video is by Gary Kasparov. Okay, Gary Kasparov was a chess genius, and he was the last person to win against the machine. And after that, they brought DeepMind or some. I think one of the companies got in a very very advanced chess engine, and he lost to it. So that's why in the Newsweek there was an article called "The Brain's Last Stand," and I'll share this is TED Talk by Gary Kasparov and what he thinks about machine and how he thinks we should use the machine to our best of the capacity and build better systems and because he's the rightmost authority because he fought the machine. Okay, he was genius. I mean, it's really next level chess player, right? And he lost to the machine, and now he has a beautiful talk. And this 12.55 is I wanted to show you the best of his talk comes after this 12.55 minutes. Right? It's a 15 minutes, but in 12.55 he really talks. So I'll share this video. You can watch it when you have time. Let me summarize and let me show you other tools or how you deploy something. So you have ready-made softwares to deploy your predictive maintenance problems as well. These softwares like Azure IoT Hub, ready-made, AWS IoT Core. These are all already ready. If somebody really wants to experiment, or anyone of you want to do helps your PhD scholars or do an internal project, or get some projects from industry to do an experimental project within, try to explore these concepts, Azure IoT Hub and AWS IoT Core. Just build something in your lab, or you may have mechanical department where there could be some machine which is what some machine which is moving right? So there is vibration, there is a temperature. Just take vibration and temperature. Okay, just take this data, sense this data, attach this data, and buy a subscription of Azure IoT Hub, and direct this data to be collected on Azure IoT Hub. On Azure IoT Hub, you will get ready-made software, ready-made machine learning models. So just collect that data and put that, train that model there only. It will do everything. Then you predict in real time, and then you try different vibrations and temperature and rotor speeds and gear for your small machine, and you'll actually see how you can actually improve, or you can build a solution for somebody as a part of your college or your university. That can, it's very much possible, and it is something which can bring you funding. Okay, imagine the number of factories and plants that are there in India. I know many industries. Suddenly they tell me your transformer got burst, and now I'm running lost. 10 days I don't have the product to deliver, right? And I keep thinking why predictive maintenance is not established here. So we are in talks with many people, known people, to experiment with this. But we need people, we need collabs, we need professors, researchers to put in their head. And every problem is different, every vibration level is different, every data set is different. So we need people, scientists, to think about and tailor the solution, right? So a few real-world applications that we see. Solar panel. For solar panel, what all you will collect? Challenge. What is the challenge for solar panel? Dust accumulation, overheating, right, which leads to efficiency drops. So data, temperature you will collect, irradiance you will collect, power output you will collect. What kind of AI solutions you have for that? You train a regression model to predict panel efficiency based on real-time data. Okay, so set up an alert system for cleaning when efficiency drops below a threshold. Correct? So what technical things you need for it? Collect all historical data from sensors, and you collect for a particular temperature, for a particular irradiation, for a particular power output from solar panel. How much was power output for a particular temperature irradiation? Right? How many? What was the last cleaning? What was? How many hours uh, since you cleaned that panel? You can collect that data also, and you can make a relationship saying that if you leave the solar panels not clean for a long time, there will be dust accumulation, and that irradiance will drop, and eventually your your solar panels power output will be dropping because of that dust. You will not actually um, get that much heat from that this one, right? You will not illuminate those solar cells. So it makes sense, right? So for that, you train a machine learning model using XGBoost or random forest to predict efficiency. Another case study would be, I think, yeah, I'm at the end of it now, so don't worry, just another 2 3 minutes, right? So wind turbine, you can have challenges about blade erosion, gearbox failures, as we just saw earlier. Battery systems are also there. The challenge is degradation of battery in solar farms. And what data you want to collect, charge cycles, temperature, voltage, what kind of AI solutions predict the remaining useful life using regression models like gradient descent, right? So all these systems are there, and hope we are able to cover everything. So I'm at the end of this thing. So the challenges usually are the quality issues, which is if you don't use good sensors, sensor inaccuracies and missing data are actual challenges. The complex environment is also a challenge. Overcoming challenges with AI, use data interpretation techniques, implement cloud-based solutions, apply transfer learning to reduce training time for new equipment. Right? But these are all key concepts. This concept is very, very important. Transfer learning. That is obvious, right? Transfer learning means what? Transfer learning means you have already built a model on previous equipment. Again, we are not going to build a model. So we transfer the model just by adding a little more knowledge to it, right? There are facilities there. I mean, you already built a relationship is there, so you tune that relationship with newer trends. Future trends, emerging trends, edge computing, digital twins, integration of edge computing is what machine learning. Instead of you collecting all the data and then building the machine learning model, on the cloud, you build the model and deploy the model on the edge itself. I mean the chipset itself where it is collecting the data, right? You don't have to put it to the cloud. That on the edge itself it will compute. That is what it's computing. Now digital twin is something which you may know. You will exactly create the digital twin, digital simulation of that entire wind turbine. Whatever is happening there is happening in your simulation. So it is much easier because, but then again, it requires a sensor. So it is sort of the same and probably a costlier solution. But if you build a very complex system which you don't want to open every time, so while building only, if you put the sensor inside and you sense it with proper high grade sensors, you don't have to open it. You can completely simulate what is happening in your virtual environment. And integration of blockchain will secure your transactions, the logs that are there. Nobody can mess up with it. And there is a lot of problems here because cybersecurity is such that people can hack even these systems, and they will hack it in such a way that they can destroy this just by injecting malware into the mainframe what do you call that firmware of these machines, right? And what is next? What next in AI renewable energy? Increased use of autonomous drones for inspection. Big machines are there. Why don't you send a drone only there to just take a picture of it and get those better predictions in terms of image processing? So that's all. So I will just open up this one for question and answers. And if anyone is interested in future collaborations in research, or you want to invite our team for academic workshops for the students or for faculty, that's my number on the screen and that's my email ID. Please feel free to connect. Right, with that, I will thank you for the time and I hope I've been able to add value to your time.
Thank you, sir.
Thank you, sir. Thank you.
Any questions? Okay, sir. Thank you, sir. Thank you for your deep discussion about AI for prediction maintenance and also importance of is a data tap and importance of is a AI techniques and different learning, machine learning importance and wind turbine data by using wind turbine data to design any machine on basis of is a data required to design any type of is a machine. And also we are getting a lot of information about the importance of is a machine learning
Right.
for your bright futures. So our bright futures, sir. We are waiting for your 10x talk, sir. So thank you, sir. Thank you for your valuable information.
Thank you, sir. Thank you. I'll disconnect, sir.
Okay, sir. Thank you.
Thank you, Shubhashini. Thank you. Thank you all. Bye bye.
Okay. Good evening, all. It is my privilege to welcome you all to the Atal Online 6-day FTP session 8. Now I request B. Sandeep sir present brief report of the today's resource person, Dr. Venkatramana Viram Shetty, Professor in SR University.
Good evening, sir. Good evening, everyone.
Good evening.
Myself,